Hello, and welcome back to the Inside Java podcast, a podcast about everything Java brought to you directly from the team at Oracle that builds Java. My name is Chad Arimura. We have our Java steward, Alan Bateman, and today we're talking about JDEPS 403, Strong Encapsulation. Alan, before we begin, why don't you introduce yourself?
Yeah, I'm Java steward. I'm actually working on the JDK a long time. I guess at the moment I'm mostly focused on Project Loom, but people will remember me from modules and spending years modularizing the JDK. I've worked on NIO for several years. I spent several years working on serviceability and JVM TI and agents and attach mechanisms, heap dumps, and blah, 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 blah. Lots of things going back over a long time. So I am working on the JDK a long time. It's a very precious platform and technology. I feel lucky to have been working on it for so long. An important thing for me is to keep technology moving forward, keeping the platform moving forward. We need to have something to leave to our children in whatever, 20, 30 years, whatever it is.
Yeah. The number of projects and frameworks and hard problems I see you solve working with either customers or frameworks or people in the community ecosystem, it's really like you seem to be at the center of a lot of the sort of difficult problems that have helped move the community forward. First, I want to really commend you for that.
The Java platform requires many different skills and many different people. As you know, it's a very large ecosystem. Dealing with a large number of people that are interested in this technology requires a lot of people. But there are some people that need to work in the basement and replace the foundations on the houses as we move from release to release. And some people are better at that, some are not. And some of the bigger projects take a long time. They require spending a lot of hours working on things that many people don't care about. They just assume that they work. I mentioned they're working on or spending a lot of time on Project Loom now. There's a lot of things under the covers that most people they will just assume it works. But to get whatever it is to work takes a huge amount of effort under the covers.
Right. I come from the startup world where I've spent most of my career, and the thing about startups is you spend most of your time just trying to be heard by anybody who will listen. I've been on the Java team now for maybe almost 2.5 years, and it's been really incredible to watch how the process is completely different because it's like the complete opposite of a startup in the sense that half the world uses Java in some form or fashion. And to watch how a platform needs to progress while, taking into account that sort of scale and mass is pretty incredible to see.
I'm always impressed with things with projects like space projects, that takes 10 years or whatever to get to Pluto or something like that. And they work on it for 10 years, set it off into space, and fingers crossed it'll actually work when they get there.
Yeah.
And then having people that are actually around from the beginning of the project to the end is always impressive too.
Yeah, for sure. So I think that's a good segue because JDEPS 403 around strong encapsulation has been a journey as well. This isn't just like a JDEP that got introduced and we're talking about a new feature here. This goes back really to modules and even before actually. So I want to start back you can go back further, but maybe around 2015 where the team started talking about the release of Java 9 module system and how two of the big features were reliable configuration and strong encapsulation. And at the time, it was announced that it would be sort of relaxed strong encapsulation. Do you want to start there and talk a little bit about our progression from relaxed strong encapsulation with Java 9 and how we've come from there?
Strong encapsulation and reliable configuration were the main goals of the module system. I guess in 2015, some of those things may have been surprising to people because people didn't understand what strong encapsulation actually meant. We had before that the beginnings of some kind of encapsulation. The Java C compiler, for example, going all the way back to JDK 6, had something what was called a symbol table. So you started to get errors at compile time if you started to use internal APIs. People figured out how to bypass that. And dialing it up in JDK 9 then was going to be interesting. So you went back to 2015, which is where we had this. So that's a couple of years before JDK 9 shipped, but the initial early access builds and everything we had in that design at the time had strong encapsulation, and that was both at compile time and at runtime. You tried to use something that wasn't part of the public API, you got a compilation error when you tried to compile. Same thing if you try to use it at runtime, and that was a new thing. So up to that point, everything that was public was fair game. There was no way to actually prevent it being used at runtime. Every API element that was public in a public class was accessible at runtime. There was a whole bunch of mechanisms for security reasons that were put in, very ad hoc mechanisms in previous releases to try to keep people out of the runtime. That was really important for security because we had so many problems in the past. And now we were actually trying to bring that to the standard API and have the enforcement in the VM. That was a big step forward. Now, we didn't pull it off in JDK 9. There was a lot of things actually went on then. One thing is when you look back is that it was too much of a shock to the system. A lot of the ecosystem was not ready for the JDK essentially flipping a switch. Many high performance libraries, and there's a lot of other hackery out there that dependent on being able to get at various pieces in the JDK that were not ever meant to be exposed. The other thing is that the module system was a rocky road, really bumpy road actually. A lot of politics in there, vested interests. Mark had to deal with a lot of nonsense to get that through. In the end, there was a compromise, and that compromise was the relaxed strong encapsulation that we had in 9 and persisted all the way up to 16, which was at runtime, all of these internal APIs that existed in JDK 8 would continue to be accessible at runtime for the foreseeable future. Now, the switch eventually switched in JDK 16. And the idea then was during that period, that it would give the ecosystem time to adjust. There was a simple command line switch that you could run JDK 9 all the way up to 15 with, and be able to actually try out an application to see, did it actually run without any access to internal APIs. Another big part, just to go back to a shock to the system, is that I think most people in the ecosystem kind of accepted that calling a Sun.star API is a bad idea. It's not good for the integrity of the platform. It's not good for security. It's not good for maintainability. But the idea that it extends to the reflective APIs, I think, was probably the biggest shock to the system. People realize, hang on, I can't use this backdoor called set accessible to kick down the door and get at anything inside the JDK anymore. Oh, that's a big shock. So there was a lot of people kind of react to that. I guess the other thing as well to say about that particular time is there was a lot of confusion over Sun Misc Unsafe. When people thought, oh, the JDK is going to prevent code from accessing JDK internals, that's going to prevent access to Sun Misc Unsafe. That was never the plan. My colleague Paul Sandos wrote a slide deck many years ago called, what was it called? Poking the Bear, which is exploring how to actually eventually sort of reduce the surface of Sun Misc Unsafe. And doing that is hard. A lot of the ecosystem would react badly to that, and that was never the plan to actually to do that. That's very much a longer term kind of effort. Anyway, just back to where we were talking about is that many things coming together meant we ended up having relaxed strong encapsulation. That meant that all these old hacks that where people were relying on access to internals, they would just sort of continue to work, assuming there hadn't been significant refactoring of the JDK. And by the way, when I use the term hacks, it's I don't mean it in a really negative way. There's all sorts of reasons why people end up actually accessing JDK internals. There's many high performance libraries out there and frameworks out there that they want to get every ounce of performance. And if they can bypass something to get at something privileged in the JDK, that's quite interesting. My colleague Alex Buckley likes to refer to some of these the maintainers of this as people like jetpacks. So that, if they can increase the performance of something by being able to get at some internal API and make their make their jetpacks go faster or go into higher altitude or something like that, then they'll want to do that. Bypass all the safety mechanisms. They don't want seatbelts. They want faster jetpacks. So what we ended up with in 9 was essentially two mechanisms. Is this thing that some people call the kill switch, which was just basically one command line option that you could set it different ways. The default was to allow code outside of the JDK to be able to continue to access internals at runtime, and you could set that in different ways. You could switch it to disallow or deny. Actually, was the value chosen, and that would essentially block access to internal APIs. And people could run with that and see if they have any problems. There was also a mode called a debug mode where you could give it a value of debug and you could actually get stack traces and other useful information, which is very informative to get some idea is, do I have code on my class path that actually relies on access to internals? Then I can turn on this option and I can get stack trace and see exactly where that code is. So that's actually quite useful. And that was the status quo up until Java 16.
So I forgot to mention the most important part. I dressed for the occasion. I don't know if have you seen this shirt?
Oh, wow. Are they chainsaws? Illegal reflective access. Really good.
I was showing off my shirt where Duke is juggling chainsaws and it says illegal reflective access on the back.
Okay, so I have never seen that T-shirt, but there's actually a great discussion point around that, because one of the things that disappointed me a little bit about some of the ecosystem's reaction to illegal reflective access was with this relaxed to strong encapsulation, there was a warning, at least for the first usages of that we know would actually fail, and the motivation for that was to provide a warning at runtime that code that is doing something here that is going to stop working in the future. You need to think about that and report it to whoever maintains that code. That's maybe the first time that we've ever actually emitted a warning at runtime. That annoyed people. The intention wasn't to annoy people to the point of that sort of react to it in a negative way. The idea was to be able to actually try to motivate people to do something about this code that we know is going to break in the future. And I guess one of the things that was a little bit disappointing was the reaction by the maintainers of some libraries. So we're in this large ecosystem. We're all sort of in this together. There's the core platform. There's a lot of really, really important libraries to the ecosystem that sort of gravitate around the JDK. And then there's a much wider set of developers that are using the platform. And it's important that we all actually work together. And so when the libraries want to put effort into hiding the warnings or bypassing whatever the check is, that's a little bit disappointing, when really what I think in order to move forward is we need to actually just reduce the usages of these internal APIs.
You talked about how we've come to JDK 16 with relaxed strong encapsulation. Just to complete the arc of the story here, what changed in 16, and then how does that lead into 403, which is coming up in September with JDK 17?
So the big change in this story was JEP 396, strongly encapsulate JDK internals by default. So Mark wrote up that JEP, which is essentially the switching of illegal access equals permit to illegal access equals deny by default. That is a JEP that is a bit of a shock to the system. What that means is that code that was depending on access to internals may stop working in 16. Now, some libraries have kept up, or they've got fallback mechanisms where they can work without it. But for some, either unmaintained libraries or then this may be problematic. But what's with that switch, you don't get warnings anymore. It's just the access will be denied. That means that if people have compiled their code, use sun.star with some older version, they try to run it with 16 or newer, it will fail at runtime with an illegal access error. If they've got code that's using reflective access, it means it fails with illegal access exception or an inaccessible object exception, depending on which API they're actually using. The important thing to say is none of these JEPs touch SunMISC unsafe. So that remains accessible, and maybe we want to talk a bit about that in a few minutes. The important thing is at 16, the option to re-enable illegal reflective access remains. the world can continue if you're really really stuck. In addition, there are finer grain options to open or export specific packages, and the primary motivation for those options are testing, but they can also be used as a get out of jail card in the event that you somehow find yourself with a library that's depending on some access to some internals, and you want it to continue to work.
Right. Yeah, and we'll come back in just a moment, because I think talking about critical APIs is really important. But now we're coming up on September, which is JDK 17, and the topic of the podcast itself, which is JEP 403. What is changing with JEP 403?
The only thing that changes with JEP 403 is the illegal access option is obsolete. It does nothing. It just prints a warning that it does nothing, and that's it. So I don't think this is a significant change in that it's just removing the overall kill switch. I haven't seen too many deployments that are actually using this option. And the get out of jail options with the add opens and the add exports, they continue as before. So if people really get stuck, they can continue to get older code to continue to work. But we still want to motivate people to try to refrain from using internals, because it's just not good for everyone. One of the big things, actually, just to say, is that with the new release cadence, there are Java releases coming out every 6 months like clockwork. It's been great, at least from the perspective of those of us working on OpenJDK. It's been great, I think. But one of the things we want to avoid is people being disappointed when they upgrade the JDK. They should be able to just upgrade the JDK and everything should just work. If you've got a lot of code that's depending on JDK internals, and there's going to be code churn and refactoring, it's going to be very fragile, and it'll prevent people actually upgrading the JDK on its own. A big issue for people trying to move beyond 8 is that it's a full stack upgrade. And one of the reasons why people struggle to actually upgrade beyond 8 is because they've got a whole bunch of libraries that they were dependent on, things that have just code that has been completely refactored in 9 and newer. That's just one of the reasons. A whole bunch of reasons in there, but it would be really nice to be able to upgrade the JDK less painless way. We put massive amount of hours into ensuring that the JDK is compatible. There's agonizing discussions about source and binary compatibility issues and behavioral issues and things like that. None of it counts if you've got APIs and libraries out there that are so tied to internals that just prevents people from upgrading.
So before we move on to the critical APIs, I want to touch on one thing. So in 2016, I was watching some of your presentations in preparation of this, and I noticed that you had made, I wouldn't call it a prediction, but more of statements that we believe by JDK 10, which if you go back to JDK 9, we were on more or less a 3 to 4 year release cadence, that you would begin to lock down the internal APIs. And so you kind of predicted that we would be right where we're at now, right about now, in fact, which is about 3 years later, a little over 3 years. So I guess my question is, it seems like things have been progressing in the way that you had predicted them in 2015, 2016. Would you say that that's the ecosystem has kind of progressed along that path in the way that you had envisioned at the time?
Possibly we got lucky with the predictions more than anything else. It was important at the time to make it clear that we're serious about this. This is the direction we want to go. There's nothing else to say on that. I think the ecosystem has been slow, and I think part of it is JDK 8 is a bit of a drag. There was many years between 8 and 9, and people got comfortable with 8. A lot of libraries still target 8. That's one factor in why some of the libraries have been a little bit slow.
You seem to have gotten pretty lucky with that guess. I want to ask, what do you think Bitcoin's price will be in 3 years?
Oh, that's a nice one. So my crystal ball I left in the office before it shut down before COVID, so I can't actually consult my crystal ball.
That's okay. I'll wait until we get back in the office and ask you again. Okay, let's go back to the critical APIs. They're generally defined as functionality that would be difficult to or impossible to implement outside of the JDK. In other words, today there doesn't exist a good alternative for people to migrate to. Do you want to talk a little bit about those, and a little bit about why Sun, MISC, Unsafe is both popular and hard to replicate?
If you go back to JEP 260, is where we came up with the naming for what we call critical. We attempted to define what critical internal APIs were and what not non-critical internal APIs. The context for that was trying to plan out what would the implications of strongly encapsulating the core platform be, and that involved doing quite a bit of analysis on the usages of internal APIs. We were lucky to be able to do some static analysis on some Oracle products as well, just to have some additional code in the corpus to be able to analyze. And what was clear is there was a lot of usages of internal APIs. In fact, there was like an exponential decay graph really of with a really long tail of internal API usages. There's non-interesting ones. We call them the non-critical APIs, and where a lot of it was just convenience and or laziness maybe. The JDK's got a sun.star API over here. This is actually really useful. I'll make use of that. The two that stand out really are SunMISC base64 encoder and decoder. A lot of usages. They were probably the most popular that we found at the time. There's nothing significant about those. They could be written outside of the JDK. In fact, many of the others could be written outside of the JDK. And by the way, we did eventually get around to adding a base64 encoder API in Java 8. So there's no excuse for using those nowadays. But the critical internal APIs are the important important ones. It was clear that we could not encapsulate those because it would cause a lot of breakage in the ecosystem, and they can't be implemented outside of the JDK. So SunMISC on Safe is the poster child. There's a couple of others as well, but it is the main one. So on Safe is used for a bunch of different things. Access to off heap memory. There's at the time there's various ways of injecting classes, and the precursor to to hidden classes was there. There's a whole bunch of support for things like atomic operations, various fence operations, those kinds of things. Very low level APIs. You cannot write those in Java. You need either support in the VM or you need native code to be able to do these things. And typically these things are actually, the compiler has intrinsics for a lot of these, so you get actually very high performance code when using some of these on Safe APIs. That's something that could never be written outside of the JDK. There was a couple of other things as well. There's support for things like signal handling. Some people had discovered, there's a SunMISC signal in here that is very useful. I can use that to be able to intercept Control C or whatever it might be in my application. There was a few more in there. If you look at the JEP, you'll see things like SunReflect reflection. That had a method in there. It's since been removed, which was to be able to for finding out who your caller was. The Java platform has Stackwalker added in 9, which is a much better API for this. But there was logging and other libraries out there that found it interesting to be able to find out who their caller is. And then there's this thing called the Reflection Factory. Not many people might know what that is, but it's important for having a serialization library outside of the JDK. It provides a whole bunch of hackery to be able, for example, allocating objects without running their constructor, these kind of things. So that could also not be written outside of the JDK. So it's a very small list, and the label we put on at the time was critical internal APIs. We moved it. We as part of the modularization of the JDK, we created a module and called JDK unsupported for these critical internal APIs, and it exported the package with those. So it exports SunMISC with the remainder of the APIs that were left in there and SunReflect. So that's what JEP 260 has all the details of that. Now, in order to get there's quite a significant amount of refactoring and of the JDK, which possibly was disruptive for those that were actually making use of the non-critical internal APIs. But we decided that was okay.
Mm-hmm, mm-hmm. Now, you mentioned a few things that made me think Project Panama could potentially be a path forward for some of SunMISC and Safe's functionality. Do you think that's a possibility?
Oh, absolutely. So there's anyone that's doing off heap today, they've probably reached the limit of what they can do with the standard API and direct byte buffers. So they're bypassing that and going down to Sunmisk unsafe for things like allocating memory directly and managing that memory themselves. Project Panama and its foreign memory API and the memory segmenting API but that has come along really well over the last couple of releases. Now it's still an incubating module, but it's very close to being preview, and I've been very impressed actually with what they've actually done there. In addition, Project Panama has in its latest incarnation, what's in 17, has something called a resource scope, and that combined with the memory API means other parts of unsafe I think could disappear in the future. For example, there's an evoke cleaner method in unsafe, which is really people want to be able to deterministically free memory or unmapped files. Panama gives you a safe way to do this, and it gives you a way to actually to manage memory in a safe way. So it's so several parts of I think in the long term could go away from unsafe, especially in the off heap area.
Right, and I'll leave in the show notes a link to the table that lists standard replacements for the internal APIs that were impacted by strong encapsulation. So I know there's a table that I believe is attached to the wiki page for JDEPS.
Right. Yes. Actually, JDEPS was a tool we originally added it in 8, which was just to say this is even before 9. We were thinking about this. The implications of this for a long time. We did a JEP. I've forgotten what the number of it is now, where we did a whole bunch of prepare for modules or type of a JEP, where we did a whole bunch of priority work in 8, and part of that was the JDEPS tool, which is to be able to do a static analysis of your class path or a set of jar files and give a report or output that tells you if you have any static dependencies on any JDK internal APIs. It doesn't help with the reflective case, but it really helps with the cases where you actually are statically referencing sun.star API.
Right. Yeah, I'll definitely leave a link to that table, JDEPS, and also information about Project Panama, which happens to have some JEPs inside JDK 17 as well. More further progress with the incubator APIs that Panama has been producing. Mm-hmm. So there's going to be some pretty cool stuff. Yes. So we've talked a lot about encapsulating the JDK itself. A lot of this does apply to user code libraries and frameworks as well, I would assume, correct?
Oh, yes.
So how can this help a larger project securely scale its code base within an organization?
For those that decide to embrace modules, and modules are a good thing, they have a terrible reputation out there because people sort of equate it to eating broccoli, but broccoli is very good for you. A module is conceptually simple. It's just a set of packages for reuse. It's really a building block that's just larger than a package. Anyone that's actually had an application or a library that has dozens of packages will surely have wondered about whether there's something larger than a package. And so one of the great things about modules is that you can say, this part of the module is my API. That is for reuse. This part of the module is not for anyone else to use, and it's not for reuse. And that is conceptually quite a good thing. So anything when you're programming in the large, and you want something that's actually very maintainable, I think modules are actually quite interesting.
Right. It makes a lot of sense. So what do you think happens next with strong encapsulation, and how should developers be preparing for things coming in 17 and beyond?
Well, what I will say is that for those that are on 8 or 11, is if you're on 8, you can minimally run JDEPS and have some idea whether you're depending on a library that has a static reference to it, just something in sun.star. That's actually easy to do. If you're on 11 or 12 or 13 or 14 or whatever, then you can run with illegal access equals deny, and you can actually try it and see what actually comes out of the woodwork. It may be that you've got to upgrade some of your libraries or some of the tooling that you're actually using. There's other options, and you'll see these in the JEPs that you can run, for example, with a -- illegal access equals debug, and you can get stack traces just to actually identify code that potentially might stop working when you actually migrate to a future release. there's many things that people can actually to do to be if they haven't tried out, and of course 16 is released. You can try that, and there are 17 JDK 17 early access builds, so there's lots of things to try. In terms of next steps, so there's several things, areas that still need taming. We talked a little bit about unsafe. So there isn't a definite plan for it going away, but one could envisage it being degrading over time. We talked a little bit about off heap and using Project Panama. There are other aspects of unsafe that I would say are obsolete at this point. There's a whole bunch of methods in unsafe for atomic access and fences. That's all obsolete since var handles were added in Java 9. There's a few other things over time, and some of the other investments that are going that big investments mean that I think the need for unsafe will reduce over time. So areas that still need attention is agents is something where we're unfortunately part of our ecosystem is going to require a bit of taming. It would be nice to have done some of that in the last few releases, but we just didn't get the cycles to do that. I mentioned about part of the ecosystem puts its energy into, how am I going to bypass these warnings or do something to avoid these warnings? So unfortunately, one of the things you can actually do with unsafe is you can actually essentially do your own kind of lower level reflective API, but it's somewhat fragile. It involves people figuring out what the offsets of objects are and things like that. It's very, very dangerous when you get it wrong, and we somehow need to make some of that go away over time because it's just too fragile. Just to give an example, is there was something we were just in the last few months we were looking at. Some big app server was crashing. Whoa, why is this crashing here? And eventually it was diagnosed, and this code was actually using unsafe to write over the value of some fields. Oh dear, why are you doing that? It turned out to be a historical issue, but that the code hadn't been upgraded, and in the meantime the JDK had been refactored, and this field that they were walking over had been changed to use weak references, and now they were actually destroying some memory that was used by the garbage collection to track references, and it crashed. But I saw the same bug several times. That is a huge cost to investigate some of these kind of crashes. And some people write defensively and code defensively, and maybe don't run into these issues, would detect that the type of this has changed. But the point is that when you're working with unsafe, it is unsafe. You will crash the VM. You will damage the integrity of the platform. You can introduce security issues very, very easily. So we need that kind of thing to go away over time.
Alan, I really appreciate it. This is the Inside Java podcast. So in every episode, we give you the opportunity to describe a day in the life of Alan Bateman.
Oh, okay. You want to know what I do each day? My day starts early, very, very early. My mailbox is full every morning, hundreds of mails, dozens of Slack messages, many PRs to look at. That's the beginning of every day. So I'm currently focused on Project Loom, so I spent a lot of my time on that. In the wider Open JDK, though, there's always things going on. There's always documents to review. There's JEPs to review. There's CSRs to review. There's PRs to review. I could spend 10 or 12 hours a day doing that and not do anything else. A really important thing is because it's a large number of people working on this, and it's important that you help others to actually to make progress and unblock them. A lot of people they want to make progress on some particular feature or bug, and they're looking for feedback, and it's important to be able to try to do those kind of things in a timely manner so that they can be unblocked and actually make progress. One of the weird things I find myself doing periodically, well, actually more regularly than periodically, is I find myself having to push back on things on a regular basis, which I don't like doing, but that's all part of stewardship of the Java platform. People are eager and anxious to actually to move things in some direction, or they want to fix some issue or to add some feature. But sometimes when you stand back from it, or you get another set of eyes, you realize, hang on, that conflicts with these other pieces over here. Or if we held off on a little bit, there's this other feature coming along that may open up doors to doing this other feature in a better way. So trying to convince people some of these things and in a positive way is something that takes up quite a bit of my time. So my typical day is very busy. There's so many things going on. JDK it's a fun project to work on. I'm really happy that my career in software sort of coincides with the Java platform. So I'm really happy to be able to have contributed to that.
Yeah, well, us too. And I really appreciate your time. I know I've said it a few times, but I know you're busy. But hearing from you directly about some of this stuff is really enlightening and useful for the community. So thanks for your time.
All right, and thanks for having me on the show.